In this example, the first thing we want to do is determine the voltage V1 across this unknown element, and we're given the polarity that we have to use. This is going to be assumed to be a higher voltage than on the right. Now, to find a voltage, KVL is probably the way to go. However, if I loop through this source, I don't really gain much information because I don't know what the voltage is across a current source. So that just introduces another unknown. So I think the approach I'm going to end up using is to loop around this side. So looping around this side, I know this voltage, I know this voltage, I want to find V1, so all I really need is the voltage across the 2 ohm resistor. Luckily, I've given that the current through that resistor is 2 amps going this direction. If I want to use that as a positive current in Ohm's law, I have to assign this voltage as being 2 ohms times 2 amps with this polarity, so 2 times 2 is 4, and that's 4 volts. So now KVL tells me that if I start down here, I see a plus sign first, so that's 4 volts. I see a plus sign first on V1. I see a minus sign on the 4 volt across this 2 ohm resistor, and I see a plus sign on this 6 volt source. That cancels with that, and V1 is equal to minus 6 volts. Now I want the power absorbed or generated by the 4 volt source. If I'm going to get that, I need the current through the source because power is voltage times current. I can't use any of my nice V squared over R or I squared times R equations for a source because it doesn't have a resistance, so to speak. Now, I also don't have to assign my voltages and currents at the source according to the passive sign convention, so I can assign them however I want them to be. So let's say I want positive current to be going that direction. Now, if I do KCL here, I have 2 amps coming this direction, I have 2 amps going this direction. So I have a total of 4 amps going in, so I4 has to be equal to 4 amps. Now, I don't need to assign my voltage and current according to the passive sign convention for an active element like a source. However, I do need to interpret them according to the passive sign convention to find the power. So if I want current to be going into here, I have to change the polarity on this source and say that if this is plus and minus, then this is a negative 4 volts. So now P is equal to 4 amps times negative 4 volts, and P is equal to minus 16 watts. Now, at the source, I don't need to use the passive sign convention, but I can assign my current such that it enters the positive voltage terminal. So let's say this is how I defined my current for the 4 volt source, I sub x in this direction. Now that means I sub x is in this direction. If I do KCL here again, I sub x turns out to be minus 4 amps. I've just changed the direction, so it should just change the sign. Now, when I apply my power equation, P is equal to I times V, positive current is entering the positive voltage terminal. I don't have to play with the signs, so this becomes 4 amps, or rather minus 4 amps times 4 volts, and it's still minus 16 watts. My assignment of positive current direction doesn't affect my result, which it shouldn't because that assignment is arbitrary.